Good evening. Welcome, students. Welcome to today's class. Today's class is a continuation of the series of most expected questions in EDC. First class, it was BJT, lower standards. It was very good, quite a good expected flow. Welcome to Unacademy Flux, first of all. Suresh VSR speaking to you. उसके बाद MOSFET लिया कल मैंने. I just directly came to the point. Just went to the GATE standards. That was also quite fine for me. I was quite happy. So just joining in the live chat. Hi Mukesh, hi, how are you? But then came today's class MOS capacitor. GATE standard के जो questions हैं, they look quite frightening. पक्का, they look quite frightening. So before we reach to that standards, मतलब GATE standard के questions से पहले, we learn some basic questions today. So आज ना हम लोग बहुत basic level पे discuss करेंगे MOS capacitor. So tomorrow also it will be MOS capacitor again. Actually I planned initially MOS capacitor one class, MOSFET one class. But MOS capacitor में मुझे लगा कि थोड़ी basic level questions भी discuss करेंगे, you know, something like ECE level, prelims level, उसके बाद GATE level तक जाएंगे. So once you're very comfortable with the modes today, आज modes के बारे में discuss करेंगे, कुछ questions discuss करेंगे. So just joining in the live chat, all of you. Hi, A.T. Rai, Sumer, hi, welcome all of you. Just joining in the live chat, just give me a second. Yes, I'm there in the live chat. I think it has switched on. Just a second. Yeah, coming on. Yeah. Just joined you. Yeah. So students, today's class is MOS capacitor basics, understanding various modes. So Suresh VSR talking to you in Unacademy Flux. This is the most expected question series. Today is MOS capacitor. Kal 6 December. Tomorrow also it will be about MOS capacitor. Tomorrow also I'll continue with problems in MOS capacitors. Kal problems करेंगे. आज conceptual questions देखेंगे. Today theory sort of questions. If you are confident, tomorrow we'll go to handling problems. Small derivation based questions and such things, right? So Sumer, you can always ask your doubts. Sumit, hi. Sumer, you can always ask your doubts in the last 10 minutes, 15 minutes. You can ask your doubts. So you can put it now or you can put it in the ending. Or tomorrow in Unacademy Flux, in Unacademy app, there is a doubt session for everybody, open to all. Morning 9 o'clock, you can come to that session also. So doubt sessions frequently every 1 month, every 15 days, we organize doubt sessions for everybody, not for plus students. Paid nahi, subscribe nahi, for everybody. So you can come in that also, right? So aap kal bhi aa sakte hain. But you can ask me today also. Anyway, it's fine for me. So this is electromagnetic waves going on in Unacademy app. Free mein chal rahi hai abhi. In the free classes or subscription, special classes. Really awesome response. Polarization is just started. Completed today, and tomorrow we'll be going to power calculations. So download the Unacademy learning app and surely follow us. You'll really enjoy it, students. कल power calculation शुरू होगा. आज polarization हो गया. So कल के बाद again it will be on 11th only. Special classes will resume on 11th only. Then of course GATE 2022 के लिए EMT is starting. Right now it's starting for electrical and ECE common topics. Fundamentals, basics, because many people are asking for live classes. Lagbhag EMT ka batch, after Ignite batch, we are only with crash courses. I was with problem courses. Full-fledged, ekdam full-fledged, organized, systematic. Ignite batch जैसी एक और batch शुरू हो रही है. That's 2022 GATE के लिए. So do join us live, students. Because of the huge demand, I'm starting this in live again. So do join us in live. So 21st December को शुरू हो रही है. 21st December. This will be for electrical and ECE. So do subscribe with my code. That's my code VSRS22. This code will be mandatory for all the students using the app now onwards. If you are a first time login, you'll have to use that code. So use the code and log in with the app now onwards. Take it? Chaliye. Right, coming to the other aspects, my Telegram channel where you can follow me for all your doubts, my subscription codes, my all the details. So you can always connect to me. So शुरू करें आज की class with different test series, lot of test series, all this coming in free in Unacademy. and most importantly Unacademy Compact. Unacademy Compact is for electrical, mechanical and civil, not for electronics, but most subjects being common, you can write the same paper. The subjects are almost common. Additionally, you have only communications. So with most of the subjects being common, ECE students can write the same electrical paper. Otherwise, explicitly there is no electrical paper, right? There's only EC, there's electrical paper, no EC paper, so you can write in that. It's a nice exam. Pakka likhiye isko. Yeah, this is MOS capacitor. MOSFET जैसा ही है, बस MOSFET में यहाँ पे सोर्स और ड्रेन होगा और करंट फ्लो होगा. Here you don't have the flow. वो सोर्स ड्रेन हटा दीजिए, सबस्ट्रेट है, फ्लो नहीं है, गेट है, controls your carriers here, and accordingly capacitance forms here. This gate is most often a metal. It's most often a metal, but recent technologies makes it almost polysilicon. More than metal, you find polysilicon nowadays. So polysilicon is a very good conductor, metallic, almost equal to metal conductivity. So that's what is your gate. Beach oxide layer and the substrate. This is the construction. ये इसकी construction है. So now look at the first question. Look at the first question. Which of the following modes utilize the majority carriers in the substrate for the MOS capacitance formation? सबसे basic question. I think most of you should answer it. Which modes will have the majority carriers participating in the capacitance formation of the charge Q by V? क्योंकि capacitance C equal to Q by V में Q किससे आती है? Right? That's what the question is. Majority carriers किस mode में participate करते हैं? So I'm waiting for your answers, all of you students. So Sumer, Rai, Mukesh, all of you can get active. Tell me the answer. Sumit Kumar, already with the answer. Yes. Absolutely, which mode is participating in it? Accumulation mode. So what is accumulation mode, students? Accumulation mode is that condition where this gate is given with a polarity which is most often negative. So gate की जो polarity होती है, it's got to be most often negative. So once this is negative, it will attract all your holes, positive charges. So that's where if you understand the positive charges coming, holes coming, this is what becomes plus. Positive plate of the capacitor और ये गेट को नेगेटिव प्लेट ऑलरेडी नेगेटिव वोल्टेज दे रहे हैं. So that this silicon dioxide SiO2 oxide layer acts as a dielectric. That's an excellent capacitance formation. This is called as accumulation mode. So I hope all of you know this. मतलब इस लेवल पे तो नहीं हो कि you don't know accumulation mode. Very happy. लाइव चैट देगा, समझ गया मैं. So accumulation mode में यहां पे जब प्लस हैं, यहां पे जब माइनस हैं, what is your capacitance equal to? Alpana, Mandal, very good. Mukesh, Sumer, Rai, all of you, beautiful, beautiful. तो जब आपको इतनी कॉन्फिडेंटली accumulation mode पता है, what is your problem in writing that your capacitance C is just nothing but Q that got accumulated because of the voltage across the oxide layer? That's it. If you write Q, this is charge, but if it is coulombs per meter square, then it will be farads per meter square. So that this capacitance COX is nothing but epsilon by width of the oxide layer. So I'm very happy, students, that tomorrow when I do any problem in accumulation mode, you won't search for problems, you won't search for formulas. सर इस प्रॉब्लम में कौन सी फॉर्मूला अप्लाई करनी है, कुछ अप्लाई नहीं करना है. The voltage that you give across the oxide layer and the charge that accumulates can be calculated by the width of the oxide layer, epsilon of the oxide layer, anything like that. हाँ, एक छोटी सी प्रॉब्लम आ सकती है, एक छोटी सी डिफिकल्टी आ सकती है कि sometimes they may give you not this voltage across the oxide layer. अगर वो गेट और सेमीकंडक्टर, गेट या सबस्ट्रेट के बीच में वोल्टेज दिया तो हाउ विल यू कैलकुलेट? मतलब अगर आपको कैपेसिटेंस कैलकुलेट करना है तो Q by V है, V इज वोल्टेज अक्रॉस द ऑक्साइड लेयर. बट इफ दे गिव यू द गेट वोल्टेज, हाउ डू यू गेट इट? सिंपल. गेट वोल्टेज इज नथिंग बट अप्लाइड अक्रॉस टू थिंग्स. अगर क्वेश्चन में गेट वोल्टेज दिया तो भी आपको कुछ दिक्कत नहीं होगा, क्योंकि गेट वोल्टेज जो भी है, जो गेट वोल्टेज है, इट इज कंज्यूम्ड इन टू पार्ट्स. वन पॉइंट इज अक्रॉस द फ्लैट बैंड वोल्टेज. जो बिल्ट इन पोटेंशियल है ना, मेटल और सेमीकंडक्टर के बीच में बिल्ट इन पोटेंशियल, उसे ओवरकम करना है, तभी तो होल्स आएंगे ना. सो होल्स आने के लिए बिल्ट इन पोटेंशियल को ओवरकम करना है. So VGS, whatever the VGS is, it is consumed in the built-in potential plus the VOX. That built-in potential is what is called as flat band voltage. Minimum voltage required for both the Fermi levels to be same. Metal का अलग average, semiconductor has a different average, substrate has a different average. For the averages to be balanced, flat band, for getting it flat band, for the movement of the carriers. So therefore your gate voltage is consumed in two parts. The flat band voltage, which is difference of the Fermi levels, which is also called as built-in, and the oxide layer. इससे ज़्यादा please don't struggle with accumulation mode. Any questions you want to ask me? Take 10 seconds and ask me now. Any questions if you want to ask me? Take 10 seconds. So accumulation mode तब शुरू होती है जब आप फ्लैट बैंड वोल्टेज को ओवरकम कर लेते हो, बिल्ट इन को ओवरकम कर लेते हो, तभी ना इलेक्ट्रॉन्स या होल्स या मेजॉरिटी कैरियर स्टार्ट्स टू गेट एक्यूमुलेटेड. And in the process of accumulating, इस accumulation process में the majority carriers are involved in the capacitance formation. P substrate में holes, ये N substrate तो electrons. But इनको आने के लिए the voltage you have to give in the gate has to be beyond your flat band voltage. Flat band voltage से थोड़ी ऊपर ही देना है. Yesterday MOSFET also I wanted to come down to such basic questions. But gate level I had to suddenly shift because gate asks only problems. Gate will stress only on problems, numericals. कल वही कर रहा था मैं, linear saturation के problems कर रहा था मैं. MOS capacitor also they'll ask problems only, but problems based on these calculations. They may give you oxide layer voltage, they may ask you built-in or flat band voltage, they may give you gate voltage. They may ask you charge, they may give you width of the oxide layer. Any such things you should not struggle, students. तो MOS कैपेसिटर में मेरे को लगा कि पक्का किसी भी हालत में 2 series 2 sessions होना चाहिए. Today and tomorrow only with the problems. That's why most expected questions also I made it too low in this standards like this. पक्का ना? Clear? चलिए. Look at the next question. Which of the following modes? Feel free to ask doubts anytime. Anytime your doubts can be asked, you can stop me. And I hope Rajkumar is there, all my favorite students. Mukesh, of course, is there. A.T. Rai, VT, all my favorite students joining me. Which of the following modes has the highest surface potential developed at the semiconductor below the oxide layer? Yes, this is the next question. Just below the oxide layer, which modes will have the highest surface potential being developed? Naga Vishwanathan, hi Vishwanath, Naga Vishwanath, AD Rai. कौन सी मोड में सरफेस पोटेंशियल डेवलप्ड इज गोइंग टू बी मैक्सिमम एंड दिस इज क्रूशियल very interesting because I want you to see how you step by step improve your standards of formulas. Many people told me, sir, MOS capacitor is damn tough. You teach us theory, you teach us that. No, I said nothing. You don't worry about MOS capacitor. MOS capacitor is just about knowing the modes and the possible three modes and three equations for each modes. So, Sukada, hi, inversion, 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 VT. All of you are very clear with the word inversion. Absolutely. So, what makes this new word surface potential coming into picture? मतलब ये accumulation mode में क्यों नहीं है या depletion mode में क्यों नहीं है? What makes this inversion mode very interesting? The interesting aspect of inversion mode is again the same point, students. If you watch out carefully, for the P substrate, मैंने जब negative voltage दिया था, यहाँ पे plus बन रही है. All the majorities are coming. Inversion mode is just opposite. Where in inversion mode, I should give a positive voltage. A positive voltage which is sufficiently large enough. Sufficiently large enough. एक ऐसी पॉजिटिव वोल्टेज जो यहां का होल्स को रिपल भी कर दे, which has to repel away the holes there and also bring your electrons here. So this is inversion mode. Something which is tougher. Something which is not a joke. So positive voltage ऐसा होना चाहिए कि all the holes should move away. मतलब वो फ्लैट बैंड को ओवरकम करना चाहिए, बिल्ट इन को ओवरकम करना चाहिए कि होल शुड मूव. एंड ऑल्सो बियॉन्ड दिस, इसके ऊपर, क्योंकि सिर्फ होल्स का जाने से फ्लैट बैंड के ऊपर होने से नहीं चलेगा. यू नीड इट टू बी इन सच अ वे दैट इवन इलेक्ट्रॉन्स आर कमिंग. वेयर देयर वाज पी रीजन, नाउ एन रीजन इज फॉर्मिंग. That is what is inversion mode is. So यहाँ पे minus, 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 minus. यहाँ पे plus. So now also this is a capacitor. अभी भी ये capacitor है. But inversion, उल्टा. Opposite to the substrate. Interesting thing क्या है? The most interesting thing is, it needs a large voltage, large positive voltage. Something greater than flat band, greater than the threshold. मतलब फ्लैट बैंड को ओवरकम करना है, थ्रेशोल्ड को भी ओवरकम करना है, then you get minus. But whenever a p region is there and a minus is here, p जिसमें होल्स हैं, and you have a minus here, there is always a potential difference which is large. वो सबस्ट्रेट और चैनल के बीच में जो पोटेंशियल डिफरेंस बनती है, पॉजिटिव और नेगेटिव के बीच में होने की वजह से सरफेस पोटेंशियल इज मैक्सिमम. सो सरफेस पोटेंशियल मतलब यहां पे पोटेंशियल डिफरेंस. ब्यूटिफुल स्टूडेंट्स, ब्यूटिफुल. Sumit, surely I'm coming to your answer. Frequency and surface potential that we can discuss. But Rajkumar, Fermi level means average यार. Fermi level मतलब average. तो जब हम वोल्टेज देते हैं तो एवरेजेस शिफ्ट हो जाते हैं, है ना. सो फेर्मी लेवल शिफ्ट इज वेरी लॉजिकल एंड क्वाइट नेचुरल whenever your average is changing because of a given voltage. So it's quite normal. So Rajkumar, you have to get your basics on this right, Rajkumar. वोल्टेज दे रहे हो, टेम्परेचर दे रहे हो, कुछ भी दे रहे हो, तो ओवरऑल एवरेजेस विल राइज. So all of you listen to this point very carefully now. Now this point is very, very important, Sumit. Sumit, I think I can answer your question, but still look at it. कि इस हालत में the point to understand is highest surface potential developed is in the inversion mode. Sir, accumulation mode में why doesn't it come? Surface potential क्यों नहीं आएगा? क्योंकि accumulation mode में the P substrate which is already at a positive voltage will have holes which are considered as positive voltage accumulating. So positive voltage और positive voltage के बीच में जो difference है, it cannot be maximum. 5 volt और 8 volt के बीच में potential difference कितना है? 3 है. But suppose if you look at the inversion mode, जहां पे P substrate है जो ऑलरेडी पॉजिटिव हैं और एक्यूमुलेट होने आ रहे हैं आपके होल्स नहीं. व्हाट आर कमिंग एंड एक्यूमुलेटिंग इज नॉट होल्स. वहां पे कौन हु आर कमिंग देयर, हु आर बीइंग पुल्ड देयर? इलेक्ट्रॉन्स, which is the negative charge. This is what is inversion means. सो पॉजिटिव और पॉजिटिव के बीच में पोटेंशियल डिफरेंस ज्यादा नहीं है, लेकिन पॉजिटिव और नेगेटिव के बीच में नाउ दिस इज मैक्सिमम. 13 वोल्ट है अभी. 5 एंड 8 के बीच में 3 है. 5 एंड -8 के बीच में 13 है. सो सरफेस पोटेंशियल इज मैक्सिमम when your P channel is forcibly inverted as N channel. P substrate is inverted as N channel. Any questions, anybody, students? I hope you followed Rajkumar now. Sumit, frequency ka discussion, I think we'll take some time for you, Sumit. We'll take some time. I think 2-3 minutes I'll come to your answer, Sumit. अभी आपके आंसर तक आ रहा हूं मैं. तो यहां पे आपकी गेट वोल्टेज किस किस में सप्लाई हो जाती है? What all will consume your gate voltage is, यहां पे आपकी जो गेट वोल्टेज है, it is consumed in the flat band voltage. तभी तो दोनों लेवल्स विल बी सेम. जो भी बिल्ट इन है उसको तो ओवरकम करना ही है. प्लस यू शुड ऑल्सो गिव ए मिनिमम थ्रेशोल्ड. तभी तो ये सब फॉर्म होती है, चैनल बनती है, इन्वर्शन होती है. थ्रेशोल्ड तो मिनिमम देना ही है, which is certainly greater than your flat band, plus something across the oxide layer. ऑक्साइड लेयर के अक्रॉस भी होगा, प्लस द सरफेस पोटेंशियल Vs. So the voltage you have to give technically is to overcome the flat band potential, to overcome the threshold, to overcome your oxide layer voltage plus the surface potential. इन तीनों से आपकी गेट वोल्टेज बनती है. इसमें ये फ्लैट बैंड इज फॉर नेगेटिव कंडीशंस, बिकॉज यू आर गिविंग पॉजिटिव ना, तभी तो इन्वर्शन होती है ना. सो इसको अगर फ्लैट बैंड को हटा दें तो थ्रेशोल्ड, ऑक्साइड लेयर के क्रॉस एंड योर सरफेस पोटेंशियल, दिस इज व्हाट योर गेट वोल्टेज इज. सो आपका गेट वोल्टेज अल्टीमेटली, the voltage across your gate is across 3 things now. एक तो overcoming the Fermi levels of both the sides, इसको आप इग्नोर कर लेते हैं. सेकेंड इज द ऑक्साइड लेयर, ग्रीन लेयर के अक्रॉस वोल्टेज, सरफेस पोटेंशियल प्लस थ्रेशोल्ड. दिस इज द वे ऑफ राइटिंग इक्वेशंस. दिस इज द वे ऑफ राइटिंग इक्वेशंस. Rajkumar, P substrate has holes na. Free electrons, free holes are moving na. So overall a positive charge is moving na. Electrically neutral हो तो ठीक है. Rajkumar, P region associates with a positive charge moving. N region associates with a negative charge moving. So वहां पे इलेक्ट्रॉन्स का आना, जहां पे होल्स मूव हो रहे हैं, पॉजिटिव चार्ज मूव हो रही है, वहां पे इलेक्ट्रॉन्स का आना कितना बड़ा पोटेंशियल डिफरेंस है. You got the point? Right. Any other questions, students? So these are my ways of understanding MOS capacitor. सो मॉस कैपेसिटर में 2 क्वेश्चंस आर फिनिश्ड, वेरी बेसिक क्वेश्चंस कि एक्यूमुलेशन मोड में वोल्टेज इज ओनली अक्रॉस योर ऑक्साइड लेयर एंड फ्लैट बैंड. This is what happens in accumulation mode. When it comes to your inversion mode, threshold के ऊपर देना है, ऑक्साइड लेयर के अक्रॉस भी होती है, and also in the form of surface potential. So your gate voltage is ultimately in accumulation mode quite simple. Surface potential है ही नहीं है, negligible है, pure holes के बीच में, positive and positive के बीच में. But when it comes to the inversion mode, yes, there are certain other things to count. Threshold, oxide, as well as surface potential. I hope you got the point, students. Now, third question. Something more interesting. So, accumulation mode में कुछ clarity आया मेरे को. Inversion mode में clarity आया. Let's look at one more mode and let's look at one more now. One more question now. So, इस क्वेश्चन को ध्यान से देखिए. Which of the following modes best suit for voltage controlled capacitor operation MOSFET? वेरिएबल कैपेसिटर के रूप में which of these modes suit for variable capacitor working? I hope this basics if they're clear. Tomorrow I can do any complex problem. Previous year question ho, upcoming question ho. You should know the voltages in each modes. And 2-3 formula. Surface potential का formula, depletion width का formula, Poisson's equations use करके. MOS capacitance you can handle it. MOS capacitance you can. Rajkumar is now coming on track. वो मासूम क्वेश्चन से हटके राजकुमार इज नाउ कमिंग रियली इनटू ट्रैक. 80 राय. सो कौन सी मोड में कैपेसिटेंस विल डिपेंड ऑन वोल्टेज? बिकॉज इट्स वेरी सिली टू से दैट C बीइंग Q by V, सर कैपेसिटेंस विल ऑलवेज डिपेंड ऑन वोल्टेज. ये गलत है. कैपेसिटेंस is also epsilon by D. So more than Q and V, Q will change when V is changing. So voltage double हो तो capacitance charge double होगा. So capacitance doesn't change. So you will never expect capacitance to depend on voltage in general conditions. Never it happens. So when can your capacitance change with voltage? It can change if your distance can change with any other voltage. ये जो width है कैपेसिटेंस के बीच में जो width है, ये अगर वोल्टेज के साथ चेंज हो सकती है, then your capacitance will change with voltage. So this is depletion mode. Depletion mode में एक ऐसी सिचुएशन है, very good students, all of you are answering about modes. मतलब आप सबको बेसिक क्लैरिटी है. Problems I can very easily do it, man. If you're all clear with your basic clarity, depletion mode क्या होता है? Depletion mode is that mode जो यहां पे वोल्टेज पॉजिटिव जरूर है बट लेस देन थ्रेशोल्ड. वो इतना ज्यादा नहीं कि थ्रेशोल्ड के ऊपर है कि चैनल बन रही है, इन्वर्शन हो रही है. नो, थ्रेशोल्ड ओनली विल क्रिएट योर इन्वर्शन. सो इतना ज्यादा नहीं, इट्स नॉट दैट लार्ज. सो व्हाट्स हैपनिंग? It can only ripple away the holes here to the lower regions. All the holes will move down because it's a positive voltage. So once your holes are moving down, once all your carriers are going away, यहाँ पे एक region बनती है which is having no carriers. It is depleted of carriers. So यहां पे जब carriers की कमी हो रही है, this is also behaving like a dielectric. ये भी dielectric के रूप में काम कर रही है. So this is where the point is कि ये जो dielectric बन रही है, जो depletion region बन रही है, दैट कैन चेंज विद द वोल्टेज, थ्रेशोल्ड से थोड़ी कम दिया तो थोड़ी ज्यादा, थोड़ी वेरी किया तो. So this is a very crucial point, students. This is a very critical point. कि point ये है कि now your capacitance is the COX coming in series to the capacitance because of the depletion region. So oxide layer ka capacitance is also acting. The depletion region capacitance is also acting in series. So capacitance is reduced because your C is now epsilon by thickness of the oxide layer plus width of the depletion region. इससे capacitance is heavily reduced. और ये जो width है, it is gate voltage dependent. That's why capacitance is voltage dependent. So capacitance calculations यहां पे थोड़ी सावधानी से करना है कि your capacitance on the whole here is the capacitance of the oxide layer coming in series to the capacitance of the depletion region, which depends on the width of the depletion region. So therefore यहाँ पे capacitance is also low but can be controlled by the gate voltage because width can be controlled by the gate voltage. यहाँ पे width of depletion region का फॉर्मूला जरूरी है through Poisson's equation. ऐसी इक्वेशंस देके बच्चे घबरा जाते हैं. They are never afraid of capacitance being epsilon by width, epsilon by distance. वो डिस्टेंस जब किसी वोल्टेज के साथ चेंज होती है या पॉइजॉन्स इक्वेशन से रिलेट करना है, दिस इज व्हाट विल हैंडल इन टुमारोज क्लास. कि हाउ टू रिमेंबर W, width of the depletion region, how to relate it to voltage. That's the point, students. That's where the point is. So students, I want you to be very cautious कि accumulation mode में capacitance is only that of the oxide layer. ऑक्साइड लेयर का थिकनेस ही कंसीडर करना है. इन्वर्शन मोड में भी ऑक्साइड लेयर का ही थिकनेस कंसीडर करना है. डिप्लीशन मोड में ऑक्साइड लेयर का भी थिकनेस कंसीडर करना है, विड्थ ऑफ द डिप्लीशन रीजन भी कंसीडर करना है. और ये पॉइजॉन्स इक्वेशन से उसका डेरिवेशन जुड़ा हुआ है. दैट इज व्हाट इज क्रूशियल डेरिवेशन. दैट्स व्हाट मेक्स इट वेरी इंटरेस्टिंग. And one more derivation is also there. One more is also equally important. वो derivation है, derivation है, छोटी सी formula है for the inversion layer surface potential. वो भी important है. Surface potential का inversion layer में surface potential value double the Fermi potential. So ऐसे छोटी छोटी formulas के अलावा बाकी सब it's very clear. Who is contributing to your capacitance? कौन से layers में capacitance consider करना है? बस that's where the topic is over. Students, I hope you are getting confidence now. Yesterday actually मैंने कल भी प्लान किया था कि MOSFET को ऐसा स्टेज बाय स्टेज लेके जाऊंगा, डिप्लीशन MOSFET, एनहांसमेंट MOSFET, बट 1 hour में मेरे को लगा कि आई कांट रीच टू दैट लेवल्स ऑफ गेट स्टैंडर्ड्स. तो आई डायरेक्टली केम एंड सेड सैचुरेशन एक्टिव करेंगे. आई एंजॉयड इट, फ्रैंकली आई एंजॉयड इट, क्योंकि मैंने ना डेरिवेशन डायरेक्टली किया एक्टिव सैचुरेशन, मतलब सैचुरेशन लीनियर के लिए. तो दैट इज व्हाट एग्जैक्टली गेट नीड्स एक्चुअली. बट टुडे आई एम नॉट गोइंग लाइक दैट. मोड्स में, अलग अलग मोड्स में कौन से रीजियंस, कौन से वोल्टेजेस में ऑपरेशन है, दैट्स व्हाट आई एम ट्राइंग टू टीच. आई एम एंजॉयिंग इट. Anil Kumar, hi, good evening, good evening. So the summary of the discussion is this, students. Summary of the discussion is, look at a nice summary. I mean, just before I go to the next question, before 2 questions more there are 2 more questions. Agla question se pehle, just look at the summary. There are 2 graphs I'll draw now. One graph is for the voltage VG gate versus the Q that you find in the substrate. ठीक है, considering a P substrate. So the first thing you should understand here is, what if VGS is negative? Negative दिया तो क्या होगा? All the holes will get accumulated और वो भी minimum negative है flat band से ज़्यादा. The minimum negative should be greater than the flat band or exceeding the flat band magnitude wise. Magnitude में इसको exceed करना है. जितना आप exceed करेंगे इतने accumulate होती है. So you find the charge versus the voltage accumulating beyond the flat band voltage very linearly. Very linearly. Straight line. और इस लीनियर ग्राफ का जो स्लोप है वही तो कैपेसिटेंस है. Q इक्वल टू CV, Y इक्वल टू MX. So students, this is the point to understand कि फ्लैट बैंड से कुछ भी नेगेटिव वोल्टेज दिया तो ढेर सारे होल्स आ जाते हैं. यू गेट फाइन होल्स कमिंग. दिस इज Q accumulation. Then the depletion starts, and during this depletion you don't find much charge. You don't find any charge. Gradually and gradually, of course, you may find a negative charge coming, but not linearly, but non-linearly. Why non-linearly? Because here the capacitance is voltage dependent. This is Q that is non-linearly developed because of depletion. Q non-linear है क्योंकि voltage पे dependent है capacitance. Y equal to mx ग्राफ नहीं है. और उसके बाद if you give threshold voltage, then again you find a negative charge, linear. ये भी linear, and this is Q inversion. This is non-linear. This is also linear. ये non-linear क्यों है? क्योंकि voltage dependent capacitance का working है. Revati, Raman, sure. You want to understand why it's again linear? Sure. Yeah. Revati, Raman, just listen. Q is equal C into V. Y equal to mx. M is y by x, linear. So it's linear here, where your capacitance is constant, because it is only because of oxide layer. So capacitance is coming only because of the oxide layer. So it's linear. Why is it non-linear here? Because the capacitance is because of oxide layer plus depletion region width, which is variable with voltage. So capacitance will change with voltage. So Q and V becomes non-linear, square. I hope you got it, Revati. So when C is depending on V, Q becomes V square or maybe root V. That's what is non-linear. So why is this capacitance changing with voltage? Because apart from oxide layer, depletion region is also acting into picture. Depletion region is also adding. So that's why it's non-linear, changing capacitance, slope is changing. I hope the doubt is clear. Any other questions? Take 10 seconds. If you have cleared this stage, students, if you have cleared this stage, you almost cleared 80% of the subject of mass capacitance. It's not formulas. Formulas I will also give you tomorrow. Only 2 formulas. I'll give you C equal to Q by V formula. I'll give you epsilon A by D formula. But you should first of all have a clarity on which formula to use and why are we using it. The depletion region width is considerable and important only when you're doing depletion mode of operation. Now textbooks, what they do is, especially if you go to any standard textbook, they'll give you depletion region formula even in inversion mode, which is of no use. because that calculations have no relevance in the capacitance calculation. There may be a depletion region, but that is almost filled up with the carriers. So there's no relevance for the depletion region calculation. So don't unwantedly learn formulas for every mode and confuse yourself. If I can teach a tough subject like EMT, and if you all know me as EMT teacher, I started my career with EDC. I was almost, for many years, people don't even know that I was teaching EMT. In my university, I was teaching EDC only. I never told that I can teach EMT also. So EDC is actually so basic and so simple. We complicate it. We complicate it with a lot of equations and a lot of stuff. Got the point? Right. Anil Kumar, Unacademy free classes, you can just download the app. Anil Kumar, just download the app and follow me as Suresh VSR. All my free classes will be in date-wise order. From December 11th, my last year, first class to this year. I'm just shortly going to finish 1 year. 1 year of my celebrations in Unacademy and online teaching. So I'll talk to you on when I complete 1 year also. So everything is in the order, in date-wise order it will be there. So Anil, you can follow it in Unacademy learning app. Okay. There will be free classes. Subscription, of course, you can take. Subscription goes in a very systematic order. Very systematic order subscription classes will be there. Much relevant. You can go for anything. Right. Now let's go to the next question, students. Okay. You have to identify which of the following modes have the energy band diagram as shown below. Okay. I'll show you an energy band diagram where you can see it here. Looking at this energy band diagram, we should say in what mode it is. So which of the following modes have the energy band diagram as shown below? Look at the diagram. Because without energy band diagrams, if you learn MOS capacitor, you don't do justice to your subject. Equations, problems, first priority. What I did today was bit of equations only. I was just introducing it to equations. So first priority for equations and problems. Give a small priority for energy band diagrams. Sufficient. Sufficient. Manish Kumar, EMFT means electromagnetic field theory. EDC means electronic device and circuits. Manish Kumar, electronic device and circuits. Basics of VLSA, basics of this world, basics of digital. Depletion operation is somebody saying. P substrate depletion is what somebody is saying. Okay. I think you can see the options there. I've got a few options. Yeah. So what is it that you can go for? I mean, as per the data, what do you think you can really go for? Right. Beautiful students, all of you went for, one went for accumulation mode. That's Revati Raman. Okay, Revati, just going for accumulation mode. Okay, students. Okay. Really happy with the way you're interacting. In fact, if you come to the Unacademy learning app for free classes now, the interaction is much better. Very small delay will come. Here at least 4-5 seconds delay is coming. There the delay is negligible. Almost I feel as if they're in front of me. So do join us in our Unacademy learning app. We are not, Unacademy is not somebody who has come because of lockdown. We are people who are there into online since long. And of course, I've been since last 1 year, December. Remember, December means it was not lockdown period. We are not lockdown heroes and we are not lockdown alternates. We have been there into online. So do enjoy our app, students. Right. Students, the first thing I want you to identify here is, ये तो यहाँ पे P-type semiconductor लिख दिया. So substrate, I should not again ask you what substrate it is. So undoubtedly P substrate, right? P substrate. The confusion that can come here is, one major confusion is, when it is P substrate, they generally call it as NMOS. That's why I wrote so clearly substrate, or is it MOSFET name. So P substrate is called as NMOS because the channel, as if you look at your MOSFET notations, will be N channel. So P substrate is always called as NMOS. This is one confusion that always comes. Even in my Super 30 test series, there is one slight confusion in that aspect only. Whether I ask substrate or whether I ask the MOS name. Super 30 test series, many students have asked me that. So I am clarifying it. Let's make it very clear, students. So this is one of the points I am trying to teach you कि substrate अगर P हुआ तो channel जो है उसके reference से बात करना चाहिए because MOSFET notations and MOS capacitor notation should not go opposite. So MOSFET में, as you all understand, when you have a P substrate, there will also be a channel here for source and drain, which is opposite to the substrate. So उसी notations में जाते हैं. So with that notations, when you go, students, the first point I think I'm very clear here is, as you see the diagram, it's P-type semiconductor, P substrate. And even if this is not mentioned here, अगर ये mention नहीं हुआ तो भी, the Fermi level is close to the valence band. The Fermi level is close to the valence band. So Fermi level being close to the valence band, पक्का ये P substrate है. What happened here then? यहाँ पे क्या हो गया? You find lot of negative charge coming or electrons coming and lowering your potential. Whenever you have negative charge, electrons or N region, you have a lowering of your potential. That's why even in a diode, the P region is shown with higher energy levels and N region is shown with lower energy levels. And that's why they show there is an energy barrier, voltage barrier V0. There is a height. So this is one of the things that you should associate. A positive charge, positive person has got higher energy levels. Negative people always reduce their energy levels. Negative food, negative thoughts, negative people, they reduce your energy levels. Obviously, that's how you should understand things. So if you now watch it, just Sukha the Aulkar, I'm just coming to your just coming to your doubt. So what you notice here is electrons coming and accumulating. So therefore there is a reduction in your energy levels. But did it come close to the conduction band? Did it come close to the conduction band? No. ये Fermi level अगर conduction band के करीब आ गया होता, then N channel is formed. But right now, the Fermi level is still close to the valence band. Suppose if it was further reducing like this. Suppose if the bend is much steeper bend. इतना bend हो गया कि Fermi level ना conduction band के करीब आ गया. Then N channel forms. That is inversion mode. So the students should always understand this, that if you have accumulation of positive holes or accumulation mode because of positive holes, your levels will rise, making it more close to the valence band. But if it is depletion, you find lowering of your energy levels. And if it is inversion, much lowering. This is a very crucial point, students. This is very critical for you to understand. So next time, whenever you look at this scenario, keep this in mind. Keep this point always in mind. With the oxide layer, with the metal, and with the semiconductor, if this is where the center is for the Fermi level, had it been intrinsic, if it is P semiconductor, the Fermi level will be somewhere here. This is Fermi level for the right now for the semiconductor. If you have inversion taking place, the inversion is such a hopeless situation that the energy levels will drastically drop like this. If Fermi level gets close to the conduction band, depletion वो state है where it may not really come close to it, very close to it, but still. Accumulation वो stage है where the Fermi levels go up, and it is also possible कि Fermi level can go below the valence band. जा सकता है अगर accumulation ज़्यादा हुआ तो, but such an accumulation is not possible because there is carrier limitation. उसकी doping का limitation है ना. I think that's your doubt, AD Rai. इतना ज़्यादा डोपिंग, इतना ज़्यादा कैरियर अवेलेबिलिटी है अगर इन्वर्शन में पॉसिबल है, या इफ इट इज पॉसिबल इन accumulation, then they may touch your conduction bands or valence bands, but not practically. Substrate is not that heavily doped that you can supply so much of carriers. Any questions, anybody, students? Any doubts, anybody? So energy band diagrams, you should always identify yourself, whether it is P or N substrate, whether your levels are shifting up or levels are shifting down. They'll shift down if electrons will come, they'll shift up if holes are coming. Substrate P हो या N हो, levels overall नीचे जा रहे हैं या ऊपर जा रहे हैं, वो देखना जरूरी है. And depletion and inversion में difference ये है कि level will be shifting so heavily that Fermi level comes to conduction band. Then we say N channel inversion took place. So that's where you identified. इसी डायग्राम में ना, इसी डायग्राम में अगर मैं इसको यहां से दिखा दूं ऐसा, this becomes inversion mode. This I'm stressing so much because tomorrow one formula is based on it. कल इस पे एक बहुत बड़ी formula based है. Surface potential is double that of Fermi potential. तो इसीलिए इस मोड को, inversion mode को भी समझिए. Anybody wants me to repeat? I have no objection to repeat. If you are clear, well and good. कोई questions हो तो पूछिए. 10 seconds I'll wait for you. 10 seconds I'll wait for you. Take 10 seconds time. Ultimately, textbooks and teachers should not complex the subject. Teacher हो या textbook हो, subject को simplify करना चाहिए. Problems में complexity दिखाना चाहिए. Problem कितना भी tough हो, उस simple point से बन जाना चाहिए. मैं ये नहीं बोल रहा हूं कि मैं simple तरीके, simple technique से पढ़ाता हूं. I also teach complex problems. I also handle advanced topics, EMTL हो, EDC हो, लेकिन सब्जेक्ट की जो कॉन्सेप्ट है ना वो बहुत सिंपल रखना चाहिए. You can't do just derivations like that. You can't remember formulas just like that. Minimum formula से सब कुछ, everything should be handled. Right. Come to the last question. This is a multiple selection question. And I hope you can all answer it. तो बताइए. Threshold voltage of a MOS capacitor corresponds to, what are the things that you can say? Threshold, अगर आप गेट को थ्रेशोल्ड अप्लाई कर रहे हो, फ्लैट बैंड नहीं, फ्लैट बैंड इज डिफरेंट, थ्रेशोल्ड अप्लाई कर रहे हो, राइट? तो इनमें से क्या क्या चीजें हो सकते हैं उस वक्त? Is it onset of inversion? Is it onset of depletion? Do you find the maximum depletion width there? Or do you think this is channel formation only for MOSFET but never relevant in MOS capacitor? क्योंकि कल मैं कुछ प्रॉब्लम्स कर रहा था, VGS minus VT, I was doing IDS is equal to something like Kp into VGS minus VT whole square. तो मॉसफेट में पक्का मैंने थ्रेशोल्ड के बारे में डिस्कस किया था. So do you think it's not relevant in MOS capacitor? Answer. It's a multiple selection question. All of you join me tomorrow in the Unacademy learning app. Morning 9 o'clock there's a doubt session open to all. Any student can ask me doubts. This is every 15 days we have such sessions so that students have a one-to-one interaction. ये वो scenario नहीं है where there are 400 students in a classroom and we can't talk to them individually. There were. I taught in such institutions. I taught in such organizations where there were even 400 students. They were one of the best, no doubt. But Unacademy is different. We have a live interaction one-to-one. Top doubts, you can send me in my Telegram channel. I'll clarify them all in a sequence. If not possible, tomorrow you can get live because Unacademy app supports everything. उसमें आप directly you can point questions in our app. मतलब आप क्लास में आ जाइए तो लाइव क्वेश्चंस भी दे सकते हैं. सो डू आस्क मी क्वेश्चन स्टूडेंट्स. अनुराग डी, इट्स योर नेम राइट? अनुराग डी, मतलब आप अनुराग ऑप्शन डीबीसी तो नहीं है ना? अनुराग. आंसर अनुराग says is B and C. I'm waiting for Mukesh, VT, my favorite students, A.T. Rai, Sumit. I'm waiting for Mukesh especially. Revati says A and C, A.T. Rai, C and D. Okay, Mukesh, ABC. Mukesh, ABC. Mukesh. No? Okay. Anindita Mandal, A and C. Beautiful, beautiful. Anurag, yes, B and C. VT, B and C. Okay. Actually, I was just worried कि कहीं क्वेश्चंस बहुत लो स्टैंडर्ड में तो नहीं है. बट मैंने क्वेश्चंस ऐसा फ्रेम किया कि टीचिंग दोस क्वेश्चंस आई क्लैरिफाइड एवरीथिंग अबाउट द मॉसफेट. तो एक सेटिस्फैक्शन था. बट लास्ट क्वेश्चन बहुत सेटिस्फैक्शन दिया मेरे को. सो मेनी ऑफ यू गोइंग रॉन्ग. ऑलमोस्ट एक्सेप्ट वन और टू, ऑल ऑफ यू वेंट रॉन्ग. आई थिंक ऑल ऑफ यू. बिकॉज इफ यू जस्ट सी द ग्राफ हैव ड्रॉन, थ्रेशोल्ड क्या है ध्यान से देखिए. एक ग्राफ ड्रॉ किया था भैया. या दिस इज द ग्राफ. ध्यान से देखिए. थ्रेशोल्ड इज दैट पॉइंट वेयर इन्वर्शन एक्चुअली स्टार्ट्स. थ्रेशोल्ड वो फाइनेटली लार्ज वोल्टेज है वेयर द मेजॉरिटीज हैव बीन ड्रिवन अवे and minorities will start to come and build up. So this is one of the points, students, in my diagram B. That's from the beginning, and this is what I'm teaching. कि ये P region में से holes को यहां पे बुलाना, excess holes को बुलाना, more than the expected concentration coming here. This is accumulation. ये आसान है. ये flat band voltage के ऊपर कुछ भी हो तो आ जाएगा. So this is not tough at all. This is not at all a tough thing. So flat band के ऊपर मतलब potential difference जो भी है उसके ऊपर दिया तो काफी है. That voltage will pull all your holes, all your majority carriers. उसके बाद opposite कीजिए voltage को और threshold देना शुरू कीजिए. Opposite polarities will start to come. मतलब the holes have to go down and electrons have to come up. ये होती है थ्रेशोल्ड. सो फ्लैट बैंड वोल्टेज और थ्रेशोल्ड के बीच में डिफरेंस यही है कि फ्लैट बैंड इज वेयर डिप्लीशन एंड योर एक्यूमुलेशन बॉर्डर इट इज. थ्रेशोल्ड इज वेयर इन्वर्शन स्टार्ट्स. वो मॉसफेट में भी होता है. चैनल बनना शुरू होती है, एनहांस्ड करंट आती है, चैनल स्टार्ट्स टू फॉर्म. VGS minus VT का मतलब वही है. So that's where the answer is. That's where the answer is. The answer is, students, it is onset of inversion, but certainly not onset of depletion and accumulation. Depletion accumulation के बीच में नहीं है. Depletion and इन्वर्शन के बीच में. And this is where the depletion region is also at the maximum, because you're applying such an voltage कि carriers are being depleted. Depletion region is maximum. फिर इसके बाद क्या होती है? इन्वर्शन थ्रेशोल्ड के बाद क्या होती है? वो डिप्लीशन रीजन में ऑपोजिट कैरियर्स विल स्टार्ट टू कम एंड फॉर्म चैनल. यहां से चैनल बनना शुरू हो जाती है. वहां पे डिप्लीशन रीजन नहीं रहेगा, वहां पे चैनल बन जाती है. You got the point? So that's also correct. हाँ, it's not relevant बोलना गलत है. चैनल फॉर्म होती है, सही है, बट नॉट रिलेवेंट विद मॉस कैपेसिटर कैसे बोल सकते हैं? वहां पे एनहांसमेंट बोलते हैं, यहां पे इन्वर्शन बोलते हैं. नॉट रिलेवेंट बोलना नहीं चाहिए ना. सो ये गलत है, ये भी गलत है. आई होप यू आर एबल टू एनालाइज इट स्टूडेंट्स. सो द एनालिसिस पार्ट इज दिस स्टूडेंट्स. द एनालिसिस इज दिस. If you look at a P substrate, gate, oxide and semiconductor, इससे कैपेसिटेंस बनती है. That's it. This is accumulation mode. The accumulation is such that gate will be minus, this will be acting as plus. This is accumulation mode. What is depletion mode? Gate, oxide, substrate. ये पॉजिटिव देने से शुरू होती है. और ये जो सबस्ट्रेट में ना, there is an extra region now. That is what is W depletion region. And somewhere here there may be minus, negligible. So depletion mode, something which you give a positive voltage, but less than threshold. Accumulation कब बोलते हैं? When your gate voltage magnitude is anything greater than flat band voltage. फ्लैट बैंड के ऊपर दिया तो नेगेटिव में मैग्नीट्यूड वाइज, थ्रेशोल्ड से कम दिया तो डिप्लीशन. व्हाट इज इन्वर्शन? इन्वर्शन मोड इज गेट पॉजिटिव ही, ऑक्साइड लेयर, और ये जो डिप्लीशन रीजन है ना, ये नहीं रहेगा. डायरेक्टली द सेमीकंडक्टर विल बी माइनस, क्योंकि यहां पे चैनल बन चुका है. डिप्लीशन रीजन नहीं है वो, स्ट्रॉन्ग इन्वर्शन. द डिप्लीशन रीजन हैज बीन फिल्ड अप एज ए चैनल. माइनस हो गया पूरा वो. दिस इज व्हेन VGS is greater than VT. Positively. You can't get a better summary than this. Get me any complex question tomorrow. I'll teach it on this basis. कब कौन सी width के साथ capacitance calculate करनी है? What all the widths you have to take for capacitance calculations? Everything I'll teach on this basis. So thanks a lot all of you students for the confidence in me. Thanks all of you for the confidence you have shown me, the affection that you shown me. सत्कार सिंह, डिप्लीशन चार्ज इन्वर्शन में नहीं होगा. Yes, सत्कार सिंह, that's a beautiful question. डिप्लीशन चार्ज लगभग फिल हो जाती है. यह है स्ट्रॉन्ग इन्वर्शन में. दैट्स अ ब्यूटीफुल क्वेश्चन. वीक इन्वर्शन में हाँ थोड़ी बहुत डिप्लीशन चार्ज होती है. स्ट्रॉन्ग इन्वर्शन में दैट इज ऑलमोस्ट गॉन. सो दैट you find a minus here. The depletion charge is not there. There is only channel charge. Beautiful question, Satkar Singh. चैनल का ही चार्ज रहती है वहां पे. डिप्लीशन चार्ज इज नेग्लिजिबल, क्योंकि आपने ना थ्रेशोल्ड के ऊपर दे दिया. तो फिर वहां पे रहेगा क्या? सरफेस पोटेंशियल रहेगा, वहां पे डिप्लीशन चार्ज नहीं रहेगा, सरफेस पोटेंशियल रहेगा। किसके बीच में? चैनल और सबस्ट्रेट के बीच में, चैनल और सबस्ट्रेट के बीच में सरफेस पोटेंशियल रहेगा। गॉट इट? 80 Rai, antennas arrays in YouTube. I just took problems only. Theory, I took problems. There are YouTube में बहुत क्लास, I've updated in my channel. काफी लोग एंटेनास के बारे में पूछ रहे मेरे को, तो चैनल में मैंने अपडेट किया. Have a look at it once. Okay. Any other questions, students? Any other doubts? Yeah. Revati, Raman, all of you, can you just put your lengthy doubts in my Telegram channel or my WhatsApp? Just put it. I'll answer such doubts, especially preparation strategy doubts. Just keep your doubts for today's class, okay? Just for today's class, if you got any doubts. Any such doubts, please log on to my Telegram channel. My Telegram channel is the same, VSR Studio. So any doubts, please log on to my Telegram channel. From that, you can get, of course, access to all my classes and even my number. Everything will be there. You can speak to me in Telegram also. In fact, you can speak to me. So keep all your doubts, because I mean, if they are lengthy doubts, it will be easy for me. Or the best thing is, come tomorrow at 9 o'clock morning live class. I'll talk to you there live. But just put your doubt in Telegram or in my anywhere you just put that doubt. I can talk to you live shortly. But just 5-10 minutes I want for today's class. That's all. Just for today's class, if you got any doubts, please put your doubts in today's class. Okay. And students, no injustice to anybody. We have full justice to every student, whether it's paid or special class. We show the same interest, YouTube or anywhere, but only for the committed and dedicated students. My teaching is only for the dedicated students who really want to get through that toppers or that top list. Surely I'll help you a lot, students. No doubt. After 20 years of teaching, that much we can surely help you. Chale. So chale, good night. Good night, students. Thank you. Thanks a lot for this session. And tomorrow we'll continue with problems in MOS capacitor. आज जितना बेसिक पढ़ाया ना मैंने, बहुत मासूम चीजें, उस पर कितने कॉम्प्लेक्स प्रॉब्लम्स आ सकते हैं देखिए कल. Such a simple thing, we can convert it into very good problems. Surely we'll make it tomorrow at 10:30 YouTube or morning 9 o'clock doubt session. You can always meet me. And do follow my EM Waves course also. ठीक है, वो भी फ्री में सब्सक्रिप्शन में चल रहा है. Oh sorry, स्पेशल क्लासेस में चल रहा है. You can follow that also. Good night, students. Thanks all of you. Good night. Good night. Thank you.